Hello, welcome to Learn DGlux5 channel. My name is Paul Sinenko, and today we're going to learn about the custom tree component. Basically, this is what we're going to build. It's a component that allows you to obviously expand, browse node branches, select anything at any level, and also it allows you to automatically expand to desired selection ID. If it's hidden, right? So which is great for searching. Why would you need this tree versus the standard tree component available in DGlux? This particular one will be great when you're working with where all the nodes are known. So you're not fetching the next level like you do, for example, with Node API. For example, if you build a tree that browses some structure where each level has to be requested, if you're dealing with, for example, navigational setup where all the nodes are known ahead of time and they're arranged in a specific hierarchical way, and you want a tree that can operate with them easier, that can find and expand down to any node that you want, and so on. Again, great application is custom build navigation. So when either you pre-build it for the user or you build a utility where user can create navigation himself by adding nodes to the tree, this component would perform a lot better than a standard tree in DGlux, which again is great in the environments where each next level of children isn't yet available and it has to be requested. Again, this component is best when all your nodes are available to you. Okay, so we're gonna start with this, right? Which is basically our sample navigation source. And just quickly to point out what's going to be needed for this to work. Really, the only parts this tree is relying on is ID of the node and node's parent ID. Right? Everything else is secondary. Obviously, we would want to have a header and name to display, maybe an icon, potentially carry some useful data. This could be anything. In this case, I chose path, for example, and default path, right? It really can be anything, right? So any number of columns that you have together with your ID and parent ID will just get carried over into the output. The output of this tree is the whole row, right? So in this case, whatever node you click on, you get the whole row, meaning any columns that you had initially will also get returned. So again, the only true dependencies are ID and parent ID. And for graphical purposes, there's also icon and header dependency, right? Because we show the icon and we show the header as the label. Any other columns are basically yours to choose and to use. We would call them metadata, and they don't affect the operation of this tree. Okay, so let's go ahead and switch to our brand new, well, let's first copy this data source. So I'm going to go ahead and copy this, and we'll start a brand new file. And we're going to paste this, and that's our start. Since we're building this as a symbol, let's go ahead and create this kind of placeholder for the symbol right away. And start building it inside that symbol. This way we can pre-configure all the symbol properties right away and pass the data through them instead of later unlinking them. So I'm going to start with a regular group. Right, and I'm going to give it just a border so we can quickly identify it on screen. Something like this. Just makes it a little bit easier to work with. And I'm going to set my canvas to be black again for so it's a little bit easier to see. All right, so I'm going to go ahead and make this a symbol right away. I call this a Nav Tree, and I'm going to jump in it by double clicking, right, and start working on properties. So we already saw what the our intended result is supposed to output, which is of course the row. So there will be selected row. As an input, it should obviously take the navigation source table, and also it's going to have an ID property, which is going to be input and output. So you'll be able to, it'll output the ID of what was just clicked, but it would also accept an input to go and select the ID that matches what you typed in or input from, via any other method. So let's start with table data. We'll call it nav table. That's our main input. Our ID, selected ID, would be a string because we're not going to rely on anything being strictly numeric. Right. And also, this will be our selected row. Now, selected row, of course, is an output only. We're not going to allow any input on that. Right? And nav table is an input. Select ID would be both. So we don't need to mark them in any other way. So let's go ahead and accept. And now we can link the nav table right away. So we can start working with the real data like this. So now we're ready to get back into here. And if we look at the symbol properties, we now have nav data passed right in. Okay, so we're going to need a few more properties, of course. So these are the core properties, but we also need a few properties to abstract our data source. So we're not relying on any particular column naming convention, but rather allow user to configure or tell our widget what's what. And then probably some styling properties. We'll come back to styling a little bit later. So first, for now, let's deal with properties to abstract our data and allow user to configure it. So I'm going to actually add a section so they're nicely separated. And I'm going to need to ask user for a few columns here. So I'm going to ask user, first of all, for the ID column name. I'm going to ask user for parent ID. Right. Also, I'm going to ask him for a label column. And finally, icon column, or maybe not finally, but also icon column, like so. And let's see. Well, I think that's it for now. We might have to add a few more things later on. I don't know yet. Again, I'm building this as I go along with you, so I don't have this completely thought through ahead of time. I never do. We're figuring it out as we go. So if we need to add something later, we'll add something later. So I'm gonna go ahead and save the symbol, and I'm gonna fill in these properties that I just created. The reason I want to do it here outside of the symbol is so that my values that I typed in are not serialized into the symbol. They're just passed in as this current instance. So as we have our table, we can tell that our ID column is actually a column called ID. Our parent ID is parent ID. If you haven't noticed, I'm actually literally taking the names of the columns as they exist in my source table and then typing them in here to pass that information over. Label, of course, will be header, and icon column would be icon. Right? So I'm going to get back into my symbol, go into the data flow, and now I'm going to need to create some abstracted columns. So basically, I'm not going to rely, as I said, on the real columns. I'm going to add a few more, I guess we'll call them system columns, which I'm going to be operating with. Because it's easier for me to abstract them now and create my own columns where I know how to refer to them in all the logical flows rather than parameterize the column name in every single case where I need to reference it. So what I mean by that, you'll see in a second. We're going to use column mapping. All right, and of course our source will be our navigation table coming into the symbol properties. right? And so here I can add abstracted columns. I'm going to mark them with an underscore so that I know that it's my system column, not the original column that came with the table. So I'm going to mark all the columns with an underscore so I know that this is my, let's call it system column, not anything that came with the original table. So I can later filter them out. I don't have to return them with my output and so on. So, for example, for ID, I'm going to say, this is my column. It's going to come from the column that I specified to be my ID, which is this. Right? And then let's add more. Parent ID will, of course, come from parent ID. Label will come from label column. Right? Icon will come from icon. Okay, so that's that. I'm gonna need a few more service column. Actually, not a few more, just one more service column. So I need a way to mark node as expanded or not expanded, right? So that my tree can basically look at this and know whether it needs to show children of a current node or collapse them. So I'm going to add one more. Right, so expanded is the name, and at this point it's going to be null, so no value in there. The logic here, if it's true, it's expanded. If it's anything other than true, then it's not expanded, right? I'm not going to rely on explicitly having false in there. It's basically true or anything else in my case. Okay, so this, this gives me all the basically service columns or machine columns. So I'm sorry, system columns, that whatever I keep changing terms because, well, there are no real term for this. Let's call them service columns. I think that's fitting. But I want these added to all my original ones. So I'm going to go ahead and enable retain columns. That gets me all the original table plus my service columns, right? Anything that starts with an underscore is my service column. Cool. All right. So I have my table prepped. Now, basically, I have what I need to manipulate and render the tree so we can continue on building this. And next step that I want to do is I want to take this table and isolate it. Right? What do I mean by that? So normally, table is an object, which means anytime table is fetched, let's say requested or obtained, it's a new object. Even though the table may not have any changes in any of its cells, right? When you re-request a table, right, it's a new object. So if you're relying, for example, on obviously we want as the new nodes are added or navigation table is modified, we want that to be reflected in the tree, obviously, right? However, let's say if you're obtaining this table from, I don't know, like a stored file somewhere using Stream Loader, right, or REST API, and you simply periodically check to see if the navigation table has changed. Well, if it hasn't changed, but you made a check, right, it would look as a new table. It would return as a new table, even though it has all the same values, which means it's likely going to go in and override current status of what you have already. So if you expanded some nodes, right, and I don't know, you maybe typed in search, you expanded some nodes, every time it's refreshed, it's going to go back to fully collapsed state, basically to the virgin state, right, as it looks when it's loaded. And that's going to happen every time you request an update for your navigation table. So to avoid that, right, to make sure we only re-render the tree when there are actual changes in the cells of a table, not simply when you requested a table and it got updated because it got returned one more time with identical values, we're going to isolate it. it's pretty easy to isolate it. We're gonna turn it from table to a string, and then from string back to table, right? So when you turn table to a string, if the table updates, assuming there are no changes to the cell, if it's simply another table that was fetched, the string will not change, right? So and then we convert that string back to the table. Then no change will be basically happen to the object unless there is a change to the string. So which means if there's new data in the table, yes, it will update. If there's no new data, then nothing will get updated. So I'm going to use a table to JSON block to simply take this table and, so not map to table, that's my bad. Yeah, table to JSON, there you go. So I'm going to convert the table to JSON and use JSON parser to convert it back into the table. So what I get is exactly what I started with, except this time this table will not see an update unless there are changes in actual cells of the table. Right? So again, this only matters if you, as your source, you use table obtained from some service. In our case, we use hard-coded table, serialized table, so that isolation is unnecessary. Nothing can change this table unless I have logic that does it, right? But I don't need to be afraid of unintended updates. However, if this table was coming from a string loader that, let's say, checks every 10 seconds to see if there was a change, well, in that case, every 10 seconds, my tree would reset to original state unless I had that isolation there. So hopefully this is clear. Anyway, let's get back into this. Get back into the logic and move on with the next step. The next step would be to create a writable table on which I can operate based on this output. Right now, it's not a writable table, obviously, even though our source table is writable, of course. All right, but here it's going through column mapping and then isolation. This is not a writable table, right? I cannot type values into it. So I need a writable table on which my tree can operate. So that's, of course, going to happen with a state block, right? And some table to which I'm going to write. I'm going to name this table temp table. I use Control Enter to save the name. I've mentioned this before, but this way not only the label of this block changes, but actually the system name of this block. So in all the bindings, you'll see a reference to temp_table rather than some table1.data. All right, so this is where I'm going to be setting that. So my state block would write to this. Right, and of course, it's going to write my isolated table. Right. I do want to keep it serialized. Remember how I always disable serialization for various state blocks? Well, when you deal with a table, and if as your result you want to receive a writable table, which this has to remain writable, you cannot disable serialization. It has to be serialized. Okay. So basically, now we need to understand how to when do we want to take what we have and set it to the temp table. And we probably want to have some options. For example, we want to allow user to enable updates or disable them, and maybe give them a trigger to force an update. What I mean by that is you can completely lock out updates. So first of all, let's name this section config. Right, you can completely lock out updates, saying like if regardless of any changes to the original table, I don't want my tree to change at all. Right, so only on load will it read the original table, right, and render the tree. But then if there are changes to your nav table after that, it'll just ignore it. Sometimes you would want that. And then maybe if you made changes, you'd want to manually say tell the tree to go ahead and re-render based on the changes. So I'm going to add two properties in here. Let's see, it's going to be a boolean, auto update, and it's going to be a trigger. Oops, not the fill, my bad. It's going to be a trigger. Force update. Okay. So auto update, I'm going to set it to true by default. So I want it actually to be serialized like that. Again, this auto update, that's considering the isolation, right? So auto update will only fire if there are actually changes in table cells, not simply you requerying the table. This guy. So in between that and this, right, we need a system that will basically do the update. So for the auto update, I'm going to use an if block, right? And I'm going to say that if auto update is true, then I'm going to use the table itself as the update, as a source for the update trigger. Otherwise, I'm going to use null. So that means if update is false, table itself cannot act as a trigger to update itself. Then I need to add my force update trigger. So I'm going to use a hub. I'm going to say, in my hub, the first trigger would be the result of this if block, and the second trigger would be force update, and then output goes into the state block. All right. Okay, so basically what's going to happen is if there's a change in the table and auto update is true, the table can be used as a trigger to write the updated value to the temp table. If I press the force update, it would also act as a trigger, and nothing else will at this time. So this is the source of our temp table right now. Obviously, when I link the table, right, it got triggered and it wrote. So there it is. So now this is a writable table. I can make changes to it. And as far as what kind of changes will be made to it, well, for example, when you expand a node, we would need to write true to the expanded here. That's one change that we would need to do, right? So let's move on. Now I think we can start building some basic visual representation of nodes and start linking those up. So there's one more step I would want to do before doing that. In order to render my first level of nodes, right, my initial kind of tree level, I need to know what are my root level items are, so I can pass them to the repeater that will render nodes. So again, according to my logic, anything that does not have parent ID is basically a root level node, right? So I'm gonna just filter. I'm gonna filter this table. So let's call this root nodes, and I'm gonna filter this table for anything where parent ID equals null, or actually let me capital parent ID, okay, or parent ID equals just empty string. All right, so that should return, right, my root nodes, right? So that's the first level of nodes that I render as is, and the rest will be recursive. You'll see what I mean. So basically, I definitely don't want to create separate symbols for for each level of nodes. So it's gonna recurse within itself based on filtering, but this will be used to render our initial set of symbols. So I can, before linking it to the repeater, and again, this tree would be the repeater, I'm gonna first create the node model manually, make it a symbol. Then I'm gonna convert this to a repeater and repeat that symbol. So let's, so again, I made this vertical. I'm gonna go ahead and add a group into this. um, limit the height, of course, to a single node. Let's do 40 pixels. Let's do 50. I like wider nodes. Okay. It's going to be horizontal. And first, it's going to have an icon, a label, and then logic, of course, and then recursion. So let's start with well, basically children, right? So each node has to have itself and a place to render its next level, children, right? So immediate children. So which means this this has to be vertical, right? And inside there'll be another group which is going to have that 50 pixels height, and this overall group will be just auto, because if you expand it to render the children, it would need to expand itself to enough height to display those children. So this, let's call this self, right? So this will be a group containing, the icon, the label, right? So basically this node, and underneath, I'm gonna add another group. We're gonna call it children. And children, of course, will be a repeater fed by the distilled list of nodes whose parent is self. Right? I hope that makes sense. And we're going to recurse this, right? So each node, so this repeater will render an instance of this symbol of itself, basically. And you'll see how that works. It's pretty cool. This way you can save a lot of time on, again, developing separate level nodes and other things. So let's just continue working on this. So I'm going to go ahead and make this a symbol. And I'm going to call it node because it's a node. And get back in here. Again, switch this to auto. And start working on self first. So horizontal, of course, and the order will be icon, label, and disclosure button, right? So plus minus to disclose. You can arrange yours however you like. This is how I'm going to do it. The icon itself, there are two ways to do it. So let's do this maybe 50 by 50. I'm going to support both font and image icon. I like using font icons, but not everyone has icon fonts. So I'm going to make it work with both. It's going to basically detect the length of the icon path. If it's a single character, I'm going to assume it's a font icon. If it's more than a single character, I'm going to assume it's an image icon. So this way it's going to do both. So I'm going to basically insert both the text for the font icon and the image for the image icon. Right. So for font icon, I have this cool icon font that I call Font Awesome, and I'm going to set the size to, I don't know, let's say 30 pixels. I don't know. For now, just put X in there. And then image, I'm just going to add a little bit margins on all sides. Show 10, so that 50 by 50 minus 20 from each side. So it's going to end up with 30 pixel image. So it's going to be about the same as a text icon. And of course, that has to be reflected in properties. All right, so first and foremost, each node has to know its own ID. So we'll do that. Then it needs the table of all the nodes, so we can write to it and make changes to its own row when you do stuff. So we'll just call it all nodes. Then it needs to know who's currently selected. Basically, I'm going to use table for that. You'll see why later. So I'm just going to call it a selection table. right? It needs to know that so it knows whether to highlight itself as a selected node or not. Right? And then there's probably going to be a bunch of styling properties that that we'll need to parameterize styling. For now, I'm just gonna not worry about styling. The only thing I'm gonna add is indentation. Right. This is the only thing I'm going to add is indentation. This will control how much the next level of children is shifted to the right, indented, right? So it's going to be a number. Indentation, and we'll set it to 50 for now. It's the same as the node height, so that it's indented exactly by 1 square. Okay, and I'm going to go ahead and accept that. And I think I'm ready. Actually, no, let me go ahead and add the label into it as well, so that when we're ready to render this, we can immediately see what's what. And by the way, we don't need any flex shrink on ourself, right? 50 pixels is the size of a node, and we don't need it to be any smaller ever. So I'm just going to add a text here. It's going to be taking up the whole thing, some font, a little bit of spacing here and there. Smaller font, maybe 18. And that's it. So now what I'm going to do is this symbol that I just made, I'm going to delete from here. Right. Now I'm ready to link the repeater. So this first level node, the root nodes, right? I'm going to link that as a data source. And I'm going to use this node symbol I built as the symbol to repeat, like this. So you see that basically my repeater repeated the first level nodes. I'm going to go in the first one. Come on. There we go. Yeah. And now, actually, hold on. Before I go in, let me go ahead and link up these properties that I need. So let's go in here. So its own ID. Well, that's going to come from a table that drives the repeater. Remember, we're only using our service columns, right, to drive all this. So we're independent of the naming convention in the original table, right? So that's fine. All nodes, writable, all nodes, right, and goes in here. Selection we don't have yet, so let's skip it. 50 pixels for indentation. Now we can go in. Okay. So let's jump in here and see see what we've got. So first we can drop map to table in here. And this already gives us a whole row that corresponds to this particular node, right? Which allows us to link up some of the items in here. So for text, let's call it label. And that's going to be, oh, sorry, violating my own rule. We're not using the original columns, only using service columns. So this, right? So that's going to be the name of the node. Make it a little bit brighter, right? For the icon, right? So here I need some logic. So let's call this txt icon, image icon. So what I'm going to do is I'm going to say, I'm going to check the length of my icon. I'm going to say that if it's 1, because font icon is a character, can only be 1 character long. And true, else false. And that's going to drive the display of this icon. And of course, the icon again, I made the same mistake. So we use an icon from the service column. There you go. And then we're going to use the same icon to display, right? Like this. Maybe it's a little big, so let's use like 24 maybe. Yeah. Right. We'll call it, make it white. And then so we're going to copy this. Go to the image icon, paste it, right? And we're going to say if it's more than one, right, then the image icon will be visible. It's false, obviously now. And the same thing, the icon would drive the URL, right? So you could either use URL or you use text icon font character. It's going to basically be able to work with both. Cool. And the label we already have. So if we accept, right, we have something like this. So we are rendering all the rows, all the root level symbols. Right now they're completely non-interactive. They don't know how to do anything. Okay, so now we can work on expansion. So let me go ahead and save this symbol all the way through. As a matter of fact, let me go ahead and save the page. So use this. Okay, we're getting right back into our symbol and into the first element. So we are going to deal with disclosure. So let's add an icon, right? So because I don't want to make this tree reliant on any assets, on any specific icons or icon font to exist, I'm going to use the basic approach to disclosure icons. I'm going to use a group to make a small square like this. So for this, let me make center alignment vertically. So it's in the middle right there. And let me add a little bit of spacing on the right hand side so it's not right up against the edge there. 10. And, of course, a border. Right, so it looks like this. Give it a little bit of rounding corners. And inside, I'm going to add a text, which is going to basically have minus or plus using some generic font. Again, you could parameterize this to use image or font icons just like we did for with the node icon. Again, I'm going to keep it like this, but feel free to modify it. So I'm going to change the cursor on this to make sure it's clickable. Right? And now I need to know what to show. Basically, if it's expanded, it needs to have a minus in there. If it's not expanded, it needs to have a plus. If you recall, we have our expanded column here. So let's build quick logic based on that. So I'm going to say if expanded is true, then minus, otherwise plus. Right. Also, it needs to write to the table. So first we need the universal condition on which row to write. I'm going to use a concat. Concat would be ID equals to something. Of course, it's going to equal to its current ID. So whatever ID you're working with, let's actually grab it from a dedicated property since we have it. Right. So this is a condition that's going to be used for all blocks that write to the table. Right. And now we need to basically make this button, this disclosure button, actually write to the table to set our disclosure parameter, right? The expanded parameter. So as you recall, we've just added this universal condition. That's going to be just needed anywhere. So let's use edit row block. Right, and the condition will be this. The table we're editing will be all nodes, as always. And we're going to be setting expanded to the opposite of what it is now, meaning that if, so let's duplicate this. So if it's nothing, so if it's true, then we want to set it to false, else to true. There we go. And of course, this is going to happen on click. Okay, and there's one thing left here. Now, not every node has children, and those that don't should not be showing this disclosure icon. So how do we check that? We should be able to easily check that by filtering the nodes for any nodes whose parent is this, right? So this is probably something we're going to need in more than one place. So let's do this in the top data flow of this symbol. So basically, we're going to need another filter expression. In this case, parent ID. Right, and let's do filter. And again, we're filtering all nodes like that. And let's count the results. So we're going to use length. And finally, actually, so this we're going to do it elsewhere. So we're just going to grab the length. Let's call this children. It's a reserved name. So call this my children. So let's bring this back up. Go here and add another if block saying that if we have more than 0 children, then true, else false. And that's just going to basically control this. Okay, so notice that first 2 nodes don't have any children, so they don't have a disclosure. The rest do, so they show disclosure. And when I click, you notice, I mean, nothing's happening yet, but that the disclosure button already responds. And if we look at the table that's driving this here, we should be able to see the expanded getting set to toggle in between true and false as we click, right? So we're halfway there. Now we just need to add actual children to the node and then recurse it into itself. So let's get back into our node to start working on children. We'll pick the one that has some, making it easier to work for us. Right? And now we're ready to address this lower part. Again, so we're going to switch the height of our parent to auto. Again, it's when you get into symbol editing, it's always going to be a fixed number of what it was when you double clicked to edit the symbol. So me setting this to auto doesn't really change anything. It just makes it easier for me to work with while I'm editing the symbol. Also, I want to make sure there's no flex shrink, right? Because it needs to expand and take up whatever space is necessary to show all its children. So I'm going to set 0 on flex shrink. And well, right now the children is nothing. Again, no flex shrink here. And let's say it's 0 pixels. Right? So it's nothing. Therefore, our overall node is only as high as self, which is what we need. So now we need to know if we have children. So remember, we did the count here, so we know we have children. We also know what they are. It's this table here. All right. So let's get both of them and run with it. First of all, we need to, we need to recurse the repeater. So I'm going to make this a repeater. So I'm going to sorry, the repeater. So this is going to be vertical layout. Right? And this table of children is going to be our data. And the symbol is going to be the same symbol, node. So I'm recursing the symbol into itself. Right? So that now has children, but it's 0 length. So we can now make it auto. There we go. And now we need to link appropriate things into it, right? So ID will come from this inner repeater ID column, right? All nodes will be passed from the original properties of a root symbol. So we don't yet have a selection table. We'll deal with it later. Indentation would also be passed through. Right? And now, well, it's kind of overlaid, but now you see it. So let's go ahead and accept. Okay, so you see how basically nodes get added. So now we're showing children for each one. So if there's metering and there's metering snapshot, that's a child. There's submeter snapshot, that's another child, which has its own children. It's recursed, but it's not indented right now. So it's hard to make sense of what's going on. So let's get back into our symbol, right? And let's get back into, well, so we just need standard indentation, right? So each, we need to know the level of, let's see, the indentation would always be, okay, so nothing on self and always some value on the child, right? So we have this space in here, so we can use the indentation to drive this left spacing like this, right? And while we're here, right, let's make this collapsible, right? So to collapse it, what do we need to do? We need to simply remove the data from the children repeater, and it's good, all of them are going to disappear. So we know if the status is collapsed or not based on this, or actually, sorry, based on this table that we're passing in to which we're writing. So here it says expanded, right? So we're gonna, let's go, let's grab our, again, our children table here, go to our children, and I'm gonna say if, right? So if expanded is true, then let's go ahead and use the table. Else, we're not gonna leave it null because null can have an unpredicted behavior. We're gonna use a blank. So I'm gonna create a table called blank, right? Initially, I'm gonna set it to this children, so it's the same exact format, but I'm gonna delete all rows, right? And it's just gonna be a hard-coded table like this. I'm also gonna delete all non-service columns as well, just so we keep things consistent. Like this. Right, so that's going to drive the repeater if the expanded is false, right? And of course that's going to go in here. So let's see what we got so far. Okay, so we have a tree that we can expand and expand further, right? And then if our data contains even deeper, right, you can keep doing it further and further and further, right? It's recursed, right? We only defined how a node works with its children and then recursed it into itself. So each subsequent level knows how to work with its children. So there you go, right? It's gonna, go on forever until it runs out of nodes in the table or a horizontal space. Even that can be addressed, but I don't think needs to be addressed in this particular widget. So now we need to basically provide some sort of a way to select a node, and of course output selection, and work with it. And here we go back to the reason we created a table for the selected node versus just a regular string property. So here I'm going to remind you what we've done. We've added this selected hold on. Selected ID here. In our render, right, we have selection table, right, rather than just actual selected ID as a string. Because if we created ID as a string, and remember this symbol is recursive, so somehow we would need to be able to create a system that on change writes the updated ID to its parent symbol, so that if you select something 3-4 levels down, right, that selection keeps getting written, propagated up and up and up until it makes it all the way to this property where we need it, selected ID, right, of our overall tree widget. By using a table, right, we can just link it all the way through, and it remains writable all the way through, and all the writes happen to the original table. So this is what I mean. So I'm going to create a table called select ID. This also potentially allows us to provide multi-selection where multiple nodes are selected. We're not going to do this in this widget, but table, of course, can contain more than one row. Right, and this table is only going to contain one row and one column, to which we're always going to write. Again, because we're only doing single select here. Right, so will be nothing there initially. It's going to be underscore ID is the column. And we're going to bind it to our selection table. And we're going to get into one of the nodes. There. And our label is going to be the clickable part. We can also make the icon clickable as well. Let's do all of them. So you can either click label or icon to select a node. Now, remember, we don't want to, make the disclosure clickable, because what if you just want to expand it without selecting it? That's why we can't make the whole group clickable. So we were making all these 3 items clickable. So let me go ahead and grab the on click from all 3, which is basically 2 versions of the icon. Only one is active at a time, but we use click from both, and the label. So these 3 items on click would select a node. So let's build logic here. Actually, so we're going to need a condition as always. Actually, no, we don't need a condition. Sorry, we just need to know its own ID, which we can get from properties. So we're going to edit rows. And we're going to be editing rows of, right, this selection table that we've just created outside of the symbol. So that's going to be the table. We're always editing row number 0. Right, no surprises there. We're setting ID to self. Right, and since we have 3 events that could cause this, we're going to use a hub. So all these 3 clicks would go into the hub. Right, and they would cause the ID to be set to the selection table. Right, so we can double check how that works. All right, so here's the selected ID table. Let's make it a little bit smaller. Right now we're in a tree widget. We're not inside the node symbol. So as we click, right, notice that only the root one actually writes its own ID, right? But the children don't. right? So because remember, this is recursed. So in order for all levels to be able to write to it, we're going to need to basically pass that table on to the children renderer, right? So we're editing a node symbol now. So we're simply going to pass. Remember, children is a recursion of this node symbol, so it renders itself basically, right? So in its properties, we have selection table, which is coming in into this node as well. So we're just going to propagate it to children render as well, like this, right? Done. So now let's look at it, right? So now any child, right, reports its own ID on click. So now that we know who's selected, we can actually affect the look and feel of selected item. So for that, let's make a selection and then go and edit the node that's currently selected. And we'll make a comparison here. All right, so we need to compare its own ID, which is 10 in this case, with ID of currently selected item. This is where if you had multiple selection, you would just filter the selection table for a current ID. If you have more than one result, then you know your current node is among the selected ones. We're doing only one selection item at a time, so that's why I can always look at row 1, or row 0, of course, of the selection table. And if my ID, so ID of a node that's currently I'm looking at, equals to the ID of the node that's currently selected, then I can do stuff. So I'm just going to do true false, right? And then based on this true false, now I can link the visual parameters. Again, normally you would parameterize that. So you would actually create properties where a user could say the color of the selected node, the color of the hovered node, the color of this, right? And you would simply have if block saying if true, then use that color, if false, use that color. In the interest of time, I'm just going to hard code those colors. So for example, for the fill of overall node, kind of self node, so I'm going to bind this. First of all, let me name this. Called is selected. So I'm going to bind this with a control to get the binding dialog option on Mac, I believe. And I'm going to say that it's going to be a Boolean map. When true, let's make this slightly lighter. And false would be no fill, like this, right? So now we'll have very basic indication of what's selected. Okay. By the way, the reason, so you can see not all nodes have an icon. And for those that don't, I'm not allowing space. So it looks like it's not indented. It looks like the text and labels aligns because there's no space holder for the icon. Again, it's a visual quirk. Feel free to treat this any way you want. For example, you can have a space for an icon even if icon is not supplied. So instead of so there will be empty space here, which will indent the text properly. You can do that way. I'm gonna keep it as is because I don't consider it to be a big problem. Okay, so we have everything now, other than outputting the selected row, which now becomes very easy. We have selected ID. All we need to do is filter the table for the node that matches this ID. So let's go ahead and use a concat block to create that expression. So ID equals, and close the quote, and then just going to link that right here. All right, and we're going to filter our overall node table. All right, nav table for that ID, which will give us a one row of data. Sorry, we need to filter this table here. There. So this gives us one row of data together with service column. Okay, let's do this. Let's just so we don't have to include the service columns with output. So yeah, let's filter the original table without the service columns. But because original table doesn't have underscore ID, yet we know what ID column name is, let's add one more parameter, right? So instead of underscore ID, we're gonna grab whatever we call the ID column here, there. And that's going to be output. Sorry, what am I doing here? That's going to go into the selected row, right? Okay, we're getting closer. What we're still missing is, first of all, ability to read the selected ID and set it so that if from the outside, by other means, if you want to force a node to be selected, you should be able to supply this ID and the tree should be able to select that node for you. That would happen again by writing this on change. So let's do this. So let's say that it's going to be edit rows again. So I don't need that. This is the table. Condition is always the same. Row equals 0 because our select table always contains one row. And we're going to set column ID to whatever comes in here, right? And that's going to happen on change like this. Let's see how this works. Okay, first of all, clicking works fine. Right, expand. Let's see, the ID of this item is, oh yeah, we need to output the ID. It's not being output yet. So that should be easy. Our ID would simply be linked here. All right, let's try this one more time. So, right, ID 10, expand, right, ID 12, expand, ID 14. So let's change it to ID 10, and let's try to change it to 14 manually, right? That works. Okay, so what else is missing? Let's collapse this. Let's say ID 10, that's fine. Let's do ID 14. Well, that's a problem, right? So it did select it, but it didn't expand it. So if we expand, it's there, but we would need ability to automatically expand to the selected node as all self-respecting trees would have. To aid the search function, for example, what's the point of finding something if you don't display results? So let's do that logic. This will require another recursive symbol, this time a data flow symbol, because if you think about the logic, let me go ahead and let me expand this and then get back into this. So if you think about the logic of this, get in there, go. Right. Whenever I say that a node is selected, I would need to check its parent. And if it's not expanded, set it to expanded. And then I will need to check parent's parent. And if it's not expanded, set it to expanded. And I will need to do that until my parent ID is null. That's when I know I'm at the top level, and that's when I stop the recursion. Right. So that's the logic I'm going to need to follow in order to automatically expand all the nodes all the way down to selected node. So I'm going to basically work inside out, right? I'm going to take the selected node and start checking its parents one by one. And so it's going to happen at the tree widget level. So it's not going to be inside the node level. It's going to be in here. So somewhere, move this out of the way. Somewhere in here, there'll be symbol, that will do that. So the symbol is going to be based around edit rows block, because eventually it's going to edit my nav table to set the expanded to true. So I'm going to just drop that block and convert to symbol right away. And let's call this auto expand. That's better. Let's jump into the symbol here and start working on properties first. So obviously it's going to need to take in a nav table. Right? This is a table to which it's going to make changes to the expanded column. It's going to need to know what's the ID of whatever you're trying to expand to. So let's call it ID. I probably would want to control whether it's done automatically or not. Let's do auto expand. Set it to true. And then if I don't want to do it automatically, let's add a trigger. Just go to invoke, so that you can hit the trigger and force the tree to expand if you're not doing this automatically on change. Okay, so here's what I would need to, I think, to do. So first, I would need to check for a parent of current ID. So whatever ID comes in here. So I'm gonna go ahead and apply this and link. Let me go ahead and pin these properties so we can see them. Pin, pin, pin. And probably don't need the invoke. Actually, let's pin everything here. Okay, so well, we know what goes in here. We also know what goes in here. That's whatever the selected ID is, like this. So now we can get in here with the parameters. And first, let's identify the parent of the current ID. So we're going to need to concat a filter expression. Let's move this away, which would be parent ID equals to this ID. So this will give us the parent. So let's go ahead and filter. Right. So it seems like, make sure I typed in correct, but it seems like this node 14 has no parents. All right, so let's save this and select a node. Okay, no, this node for sure has parents. We know that, so there's a flaw in my logic somewhere. So let's get in here. Oh yeah, that's right. So no, I'm mistaken here. So I don't need a parent ID. I don't need a node whose parent is the selected node. I need a node who's the selected node. And from the resulting line item here, I need its parent ID, right? And this is, and if ID is not null or empty, so let's check this. Use a case block and we'll check for both null and empty. Actually, let's do this. Let's check length. I think that'll be the most appropriate. This way, if it's zero length, so if parent is zero length, then we don't need to do anything. All right, so let's say if it's more than zero, then yeah, then enabled, true, else false. And that's going to control this state block. And the state block is going to set expanded to true wherever this. So now we need to create a condition, which would be ID equals to oh, this. So ID would equal to the parent ID of this. All right, so that's who are we going to set, and of course the table is the nav table. Okay, and this is going to get invoked, right, on basically on change of this condition, really. Right, so this will address expansion of its immediate parent, but now we also need to recurse this. So that means there needs to be another repeater inside. Right, who's who's going to be driven by a filter. All right, and so we need another concat. Let's see. So this is basically filter driven by the same thing. So condition nav table. So that gives us next level children. All right, and that's going to drive a repeater. Before we do this, before we recurse anything, right, we always want to save the page, because anytime you recurse, you stand a chance of creating endless loop and basically having to reload your browser. So we would want to save the page before we recurse this. So now that it's saved, let's get back in here. Let's see, what do we do with that? Oh yeah, I need to make this auto-sized. Okay. So let me open it a little bit differently so that it's spaced out properly. So I'm going to expand it first, and then go into edit, and then, oh yeah, so we're already all expanded. So now we're good. Okay, so let's get back into here. Oh, my bad, I don't need to be inside the node. I don't know why I did this. Here, I need to be just inside the tree. So this is our symbol, edit. So now let's go ahead and use this very symbol that we just created, auto expand, to recurse. And it's going to be recursed based on this data. And we're going to set the ID to be ID. Nav table, we're going to pass through just like we did. Right. Auto expand is also passed on. So is the invoke. And by the way, we still need to address these. And I think that's it. So now, well, let's address the auto expand and invoke. So this, oh yeah, so this edit rows, right now it's triggered by change in condition, but we need to only have that happen if auto expand is true or if you hit invoke. So let's add an if block. I'm going to say that if this is true, then we're going to pass some, I don't know, this, else null. All right, and it's going to go into the hub. Right, and also the invoke is going to go into the hub, and result is going into the edit table like this. So basically, if this is true, the edit row block will trigger itself as soon as the condition here changes, meaning that I got a new ID, which caused parent ID to change, which caused the condition to change, or I hit the invoke. I think that's it. Oh, we probably want to, let's see. So, okay, we're already disabling it if we're dealing with, of course, a root level lock. Okay, I think we're good. Let's make sure this is coming from a parent. Oh, actually, okay. So this is not coming from a service column. We need to make sure that it does. So again, I made this mistake. So this should come from here. There you go, double dash. And here, make sure the same thing. Yep, same thing. So I keep making this mistake of dragging it from the original column instead of a service column. Remember, with a service column, I always know how this is named because it's hard-coded. With the original column, I don't. It's parameterized. Okay, well, I think that's it. Let's see if it works. I can't guarantee that it will, but let's check. So we know that node 14. So let's select 10. Remember, it needs a change. So select 10, 14. Yep, it works. There we go. So we just recursed the selection symbol. So now this tree is able to search for nodes, expanding things as you search. It gives you a selected node as an output, and as well as the whole selected row and ID. And I think this is done, well, at least as far as we want to take this particular exercise. So there you go. This should prove useful, helpful to you. Again, this particular file will be attached, linked in the video, so you can grab this and modify it to your own specifications. Until then, I'll see you next time. Go build something.